Hey everybody, it's Jenny from Norman S. Wright. Last week in Northern California, we held 3 seminars on A2L refrigerants and ASHRAE 15, and they were very well attended because there's a lot of interest right now because of the refrigerant phase out. So I thought it'd be good to do a couple videos on refrigerants, starting with what is an A2L refrigerant. So let's get started. ASHRAE Standard 34, Designation and Safety Classification of Refrigerants, assigns an identifying reference letter and number to each refrigerant to classify it according to hazard involved in its use. The letter designates a toxicity class based on allowable exposure, and the number denotes flammability. So the table looks like this. A is a lower toxicity and B is higher. Class A refrigerants have an occupational exposure limit, an OEL, of 400 parts per million or greater. Class B refrigerants have an OEL of less than 400 ppm. Let me make a little bit of room here. The OEL is the time-weighted average concentration for a normal 8-hour workday and a 40-hour work week in which nearly all workers can be repeatedly exposed without adverse effects. Since the industry is primarily going from R410A to R32 and R454B, and their OELs are above the 400 ppm limit, they're classified as lower toxicity refrigerants, so I won't really go into any more detail on toxicity. For flammability, there are 3 numbers, one for refrigerants that do not propagate a flame when tested, Class 2 for refrigerants of lower flammability, and Class 3 for highly flammable refrigerants, and then there's subclass 2L for flammability Class 2 refrigerants that burn very slowly. So an A2L refrigerant has a low toxicity and lower flammability that burns very slowly. So let me move this over. Let's look more at flammability requirements. This table shows the requirements of each class. I'm just going to show the first column for now. We'll come back to the other column in a couple minutes. For Class 1, there can be no flame propagation at 140 degrees Fahrenheit and 14.7 psia. Flame propagation is defined as any combustion that moves upward and outward from the point of ignition, and psia is the pound per square inch absolute pressure. Absolute pressure is measured relative to a full vacuum. A Class 1 refrigerant may still be flammable at higher temperatures. For instance, R410A is an A1 refrigerant, but it's estimated to have a hot surface ignition temperature around 1450 degrees. A hot surface ignition temperature is the temperature at which a substance will ignite when it comes in contact with a hot surface. So this isn't a concern for daily operation, but it's good to understand what the flammability rating is telling us. Class 2L requirements is that it does have flame propagation at 140 degrees and 14.7 psia. And the LFL is greater than 0.0062 pounds per cubic feet, and the heat of combustion is less than 8169 BTU per pound, and the burning velocity is less than 3.9 inches per second. So let's make some room and define these terms. LFL is lower flammability limit, which is the minimum concentration of a substance that is capable of propagating a flame. Heat of combustion is the heat released when a substance is combusted, and burning velocity is the maximum velocity which the flame propagates. And this velocity is the key difference between a Class 2L and Class 2 refrigerant. Class 2 have all the same requirements except for the velocity requirement, which means that the flame would propagate faster in Class 2 refrigerants. So let's go back up and look at this table. You can see the requirements are all the same as Class 1, but there's no burning velocity requirement in a Class 2. Then Class 3 has the same first 2 requirements, or the heat of combustion is greater than 8169 BTU per pound. Let's move this over and look at the other columns. The requirements are the same for all 3 columns. The first column is for a single component refrigerant like R32, and the second and third columns are for refrigerant blends. Let's move column 1 off page and look at just column 2 and 3. For the blends, the second column is for the worst case of formulation for flammability, WCF, which is the nominal formulation including the composition tolerances that result in the most flammable concentration of the components. And the third column is for the worst case of fractionation for flammability, WCFF, which is the composition produced during fractionation that results in the highest concentration of flammable components. So let's make a little room. Fractionation refers to the way different components in a refrigerant blend can separate under certain conditions because each component has its own boiling and condensation points. When a refrigerant blend is in use, the more volatile components, which evaporate at lower temperatures, tend to evaporate first, while the less volatile components, which condense at higher temperatures, tend to condense first. So basically, the standard says that these two worst-case scenarios also need to meet the same requirements for flammability. Make a little bit more room. So R410A, which is a 50-50 blend of R32 and R125, and R454B, which is about a 69-31% blend of R32 and R1234YF, both have to meet the requirements of the second and third columns. Let me move this over one more time. So what does this all mean for us? Well, basically, some changes had to be made to the equipment and building designs to handle the new A2L refrigerants. Equipment and system design changes have been made, such as ignition source protection, refrigerant detectors, leak detection, piping design, testing requirements, and some others. These changes are why you can't just put an A2L refrigerant into equipment or systems designed for A1 refrigerants. There also needs to be service and installation technician training on the safe use of A2L refrigerants. So let me make a little more room. AHRI research has found that it takes 3 failures in a system to ignite an A2L refrigerant used in HVAC equipment. 1, there would have to be a significant refrigerant leak. 2, the leak would have to be sufficient enough to reach the lower flammability limit concentration, and LFL concentrations for A2Ls are above 10%. And 3, there would have to be an open flame or high energy ignition source where the concentration is sufficient to ignite the A2L refrigerant. So under normal operating conditions, in properly designed equipment and in properly designed systems, you shouldn't run into all 3 of these things. So that answers the question, what is an A2L refrigerant? And hopefully it gives you a better idea of what the classification means. If you have any questions about refrigerants, you can always contact your Norman Wright salesperson to get more information. If you have any questions or suggestions for future videos, put them in the comment below. Don't forget to like and subscribe to our YouTube channel. Thanks for watching, and I'll see you next week.